The new old stock RCA 7JP4 in the original box, and it produces a really nice picture. Welcome back to part 2, 1948 Hallicrafters Model T54 early version. You remember in part 1 I just tacked these high voltage caps in temporarily just to see what we would get. And there is one more that I can change. It's a .001 just like these. I doubt if it would make that much difference, but I may go ahead and just stick one in. Well, that didn't make any difference. Didn't think it would. I've clipped this cap loose, and I'm going to get it out of here. I'm going to look it over to see just how difficult it would be to restuff. I remember on the other one the other Hallicrafters that had these type caps, they have a cardboard that or paper that's just folded over here at the end. And I think once you get this peeled back, I think there's just a cover. These three up here made the same way. So when I tried to restuff one of these, once you heat this, there's really nothing left. This cardboard is so thin. We're just going to go with the replacements, leave the original cases out. And on this one, where I hooked it up, it's really simple. Just we'll cut these leads shorter, just mount the two caps right here. And we'll do the same thing on those three up there. Okay. 100 mic, 160 volt, both permanently attached. And the old one's 100 mic, 150 volt. So we're in good shape there. Let's move on to these three. All right, that one's gone. And here's how I accomplished that. One section went directly to pin 8 of the 6X5. So we just put it there, and there's a ground lug right next to it. So took care of that. The other section is C11B. That's a 60 mic. It goes directly to the oscillator tube in the tuner and through a resistor. And that connection is right here. So I just mounted it up here, and there's a ground lug right next to it. So another big one out of the way. And while I was into it, this resistor was mounted here. And that's a 3300 R9, I think it is. Yeah, right there. It's actually just a 2-watt. So took a 2200 and a 1000, so that gives us 3200. Tied them together in series, and I got rid of that. Also able to clean up that lug where this was mounted. The old one was mounted here and here. Okay, another large one out of the way. And here it is, C12. See the two positives going to ground. Negatives go to pin 3 of the 25Z6 and through a resistor, a 1200 ohm, right there. Here's pin 3. There's a resistor, other side of it. And then we got our positive lead, which is a red wire, goes to a ground lug. This is C13. which is right here. So positive goes to each side of that 680 ohm resistor. Negative goes to the filament string and back to the AC on that side of the switch. All right, all the electrolytics changed. And just to be sure we're working okay on the power supply, this should be 390 volts, pin 8 of the 6X5. And we've got 345. And that will vary with the AC. I'm turning it up a little higher. So we're in the ballpark. Should be good. And I reinstalled this resistor. Those two that I subbed in they were getting a little toasty, so we'll go back with the larger one. Cleaned the leads up, so it looks a little better now. This resistor, that one right there, it's a 680. And you can see it's been kind of warm, but it still checks around 700 ohms. So we're going to leave it for now. These, they've been a little toasty too, but I think they're not affecting the operation, so we're going to leave them for now. Once we get the set going, we may go back and freshen these up, put some newer ones in. So one more look at the caps. There's the 2 with the positive, that's the ground. And I use stiff wires, so they're not going anywhere. These 2 mounted right to the tube socket. That's that 390 volt source. And this one, stiff leads on it, so it's not going anywhere. These 2 mounted practically against the chassis, axial leads. These 2. And the one up here that went to the tuner tube. These 3 caps that they had bridged in. This is 40 at 450. I hate to throw a good cap away. On our solar cap checker, this is voltage here. This is 100 volts. And the light should come on then go back off on the right hand side. And there's 200. See, it went off. But on 300, not going off. And if we're going up to 400, pretty bright. And that's a 450 volt cap. So even at 300, it's leaky. Just for kicks, we'll check the capacitance. Should be a 40. So we go to our first scale. 40 is right in here. And it does check good. That's right on the 40 right there. So it is tested good. Just not 200 volts. It went off. 300, it just won't go off. So it's leaky. On 400, it should still go off, and it won't. So unfortunately, she's bad. Now, these 2 are 50 mic at 150 volt. So there's 100 volts. There, it went off. If these check good, they're probably still okay. And they're 50 mic. Again on the red scale. And they do check good. See the pi? I think you can see it there. There's a maximum opening. And we're checking between 40 and 70. So that's good on that one. Check the other one. And it tests good too. A little closer to the 40, but still tests good. Let's see leakage on it. At 100 volts it went off. We'll hang on to them. Probably never use them in a TV, but maybe in a radio restore with a good substitute. So keep these, get rid of that one. One side of the AC input went to this lug here on this rivet. And when I twisted that cap off, you can see that rivet is not super tight. So I just took it loose, put it down here on the tube socket shield, which goes directly to ground. We have a good connection there. Let's start on these paper caps. This is the circuits we'll be concerned with right now. These 4 tubes. Here, 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 and here. This is vertical and horizontal circuits. So we'll start paper caps there and see if we make any improvements. Well, I've got maybe a couple more to change, but that did make a difference. And we're up at 3,000 volts now. Now that we do have a pretty fair picture, we got horizontal scan, vertical scan, focus is working. I'm going to do 2 things. First, I'm going to check these resistors in these. This is just a voltage bleeder resistors, I call them. They use resistors to make this circuitry, make the focus work and make the horizontal work, vertical work. Just a series of resistors, and they'll tend to drift upwards in value, so we'll check them. I don't think that one belongs. We'll look into that. But several here on these controls. There's some here. Just make sure that they're okay. And then we have here, there's a circuit board here where the 1B3 and the 6C4 high voltage oscillator are. And underneath that circuit board, there's some more paper caps that I need to get to. We need to change those. And once we do all of that, I'm just going to go ahead and mount these ceramic high voltage caps, cut the leads off, get them mounted a little better, and we're going to leave them for now and see how it works. The only issue I've had with using the ceramics, they'll drift once they get hot. So we'll play it a while and make sure that they don't cause us any kind of problems. Get to those caps on that high voltage oscillator and rectifier tube circuit board. We've got leads. Got these 2, and I've already clipped them. Got a blue tracer marked on that one. These 2, and blue tracer marked on that one. And I think we have one more right here. Yeah, this black wire right here. And then we can pull that board out. And indeed that did release it. And we've got a 0.0016 kV and a couple of 600 volts that we need to change. I'll check these resistors too. Okay, 3 caps changed, 2 resistors there, and they're both good. So we'll clean this off a little, put it back in. Now to put this back, I went ahead and pulled the cage off. And it has a bottom on it with 4 screws, so I can take that off, mount the circuit board, and then run the wires through the appropriate holes there. Okay, gotta put that tube back in. Now we're ready to put it back on the chassis. These should feed right back through the holes. Now I have soldered the ends of these pairs together. We have two separate ones besides that. Didn't have too much trouble doing that. So we still have some video. We're having some bad weather here today and some snow and ice, so I use dish signal down here in the basement and modulate it over to channel 5 or 6 or whatever I choose. And the dishes went out, so we don't have any kind of a picture right now. I suspect there's ice on it. I'll have to go out and check it here in a minute. But we got those caps changed in that high voltage circuit board. We're ready to move on. My next plan here is to get back in that deflection circuit, horizontal and vertical deflection. And we're going to check some resistors around all those tubes. I did find a couple of resistors. These two 47K, someone had changed them to 15K, so we put those back the way they're supposed to be. Well, we're working okay, still not the best, but we got some tearing in the picture, especially when you run the contrast up. Horizontal wants to tear, you can see there at the bottom. So I'm going to tackle the rest of these paper caps. We'll change all of them, see if it makes any difference. All right, I think we have all the paper caps replaced. There are two electrolytics here. We'll check them before we finish up the restore. But that did help the picture. We're really stable now, no tearing. And let me put the 7JP4 in. Let's see what the picture looks like. After checking several of the bleeder resistors on this circuit board, some of them were okay, but a lot of them were 30–40% out of tolerance. So we just changed them all, even the ones that go to the controls here. So all new ones there. And we have a pretty bright picture there now. Now that we're playing okay, I want to address this selenium rectifier. Now, on the other Hallicrafters I restored, there was a fuse here, and I think that fusistor was even mounted up here. But this set just has a selenium rectifier with these two leads in and out. So I'm going to remove this and we'll do the wiring underneath. And I think I'll just put a fuse, bore a hole here in the chassis and put an AC fuse right here, but we can do all of our wiring underneath. This is an 18 ohm resistor, and this one right here goes to the anode side of the rectifier. The anode is this blue wire that was on top of the chassis. The cathode is this brown wire. And if we look, the blue wire goes to this side of the fusistor. That's it right there. The brown wire goes to pin 5 of the rectifier tube. So we can put our rectifier or our diode between here and here. Just mount it underneath. And these two wires will go away. Okay. Now let's make sure we're still working. And looks like we are. to prevent a lot of inrush current to the filaments of these tubes, because they are tied to the AC line. Turn the switch on, you have 120 volts immediately. So I put a thermistor. This is a 220 ohm cold, approximately 10 ohms hot. And what this will do, when you turn the switch on, we'll have 120 volts on this side. This voltage on the other side, it will come up gradually, and that'll put less of a strain on the tubes that are connected in that filament line. So just mount a terminal strip, 2 pins. This is coming from the switch, going down to the circuit. And let me show you how this works. We have our SIN core on about 118. Switch is off. So I have my meter on the load side of the thermistor. We turn the switch on. You can see we started about 60 volts. And now we're slowly coming up to where we need to be. A couple of minutes. We're working fine. And here's the fuse holder we'll be using. Use a GMA type fuse. And how big a fuse do we need? Well, in looking on the schematic of the other Hallicrafters I have, the later version, it has a 2 amp. And we just need to enlarge this hole in the chassis. We'll put that fuse holder right there. Here's how I wired the fuse. Now, looking at the other Hallicrafters schematic, they have the fuse wired to the ground side of the AC coming in. So I'm doing it the same way. Here's our fuse. This is coming in from the AC cord, the black wire. Connects to one side of the fuse. The other side goes to chassis ground, which is a good tie point right here on this tube socket. And we'll put a 2 amp fuse. That's what the other one has in it. So that's good enough for me. And here's our fuse holder. Cap just unscrews. And there's our 2 amp fuse. And still working good. Finished underneath the chassis. I did check these 2 electrolytics. These are relatively low voltage, 50 volt. They both check fine. We're not going to do anything with them. Leave them alone. But I have been doing some lead dressing here on these high voltage caps with some heat shrink on the ends of those. Put a little bit of heat shrink on that cap because the lead was so long. I did clean all the controls. Clean these switches on the front. Probably will do put a little lube here on this slider. You can see that this slider thing here, it goes back and forth. So we're going to put a little bit of grease on that. Make it smoother. We'll call this complete. All right, 7JP4 installed. And we have a very, very presentable picture here. I have the overhead lights turned off, but I do have a light on and the TV on the wall is on. But a nice picture. But this is a new old stock RCA 7JP4. Here's the box that came in. So this is what these little sets look like back when they were new. good contrast. I have several used 7JP4s. Here's a few of them that I'm showing you here. So let me talk about how you can test these tubes. It's really hard to get an accurate test with a CRT tester. Now, I have a Syncor CR70. It does a great job of testing CRTs, but on these you can test a 7JP4. It'll test good. You hook it up to a working chassis, which is what I have here, and the picture will be dim and washed out. Then you may test another one that tests weak, hook it to a chassis, and it works fine. Here's a 7JP4 that I took out of the other Hallicrafters that I was showing you. I had tested it previously and it was testing good, and it is. It's a very presentable picture. So we'll be using this 7JP4. Last paper cap, volume control to ground. Here's a look at the parts I replaced. We have 18 resistors, 26 of the 600 volt or less paper caps, 5 electrolytic caps, and 6 of the high voltage caps, along with one tube, the one that checked weak. So if I added correctly, that's 56 parts that we changed on this set. Did I go overboard? No, not really. All of these parts were bad, so they need to be replaced. So that's going to do it for part 2 of the 1948 Hallicrafters T-54 early version. In part 3, we'll be turning our attention to the cabinet, either repairing that old cabinet with some fresh paint or using the cabinet that we have with the other Hallicrafters. And we'll also be cleaning on the top of this chassis because you can see it when you open the top of the set. So we want it to look as good as possible. Thanks for watching. See you on the next video. We hope you've enjoyed the video. And if you did, how about giving us a like and subscribe to our channel? Thanks.